So the first time you come across the notation for an electrochemical cell in its abbreviated form, it can look a little cryptic. For instance, consider the notation for this zinc silver chloride cell. Let's work and see if we can decode this notation. The way this works is that the electrochemical cell is shown as its 2-half reaction, and we show the anode on the left. So we know anode means this is going to be the oxidation side. And on the right, we have the cathode. So we have reduction. Each of these lines, these vertical lines, represents a phase boundary. So a phase boundary is between two different states of matter, or just indeed two different phases. So it could be between a solid and a liquid, between two different solids, between a solid and a gas, a liquid and a gas, or indeed two liquids that are insoluble. In any case, we'll have a line representing that there's two different phases there. So we've got zinc chloride, which is dissolved in water, and then we've got a zinc electrode, just zinc metal. And over on this side, on the cathode, we have a cathode that's a silver electrode, but then connected to that, or against that, we have an entirely different substance, solid silver chloride salt. So these two phases are obviously not dissolved in one another. There's a boundary between them. This represents the boundary between this electrolyte and the salt bridge, and then between this electrode and the other side of the salt bridge. So we could draw this out, and I'll do that below. So this is a picture of what that same electrode looks like when we actually draw a picture of it. In our anode, we've got zinc being oxidized to zinc plus 2, and that's shown here. And in our cathode, we have silver in silver chloride being reduced to silver metal, and that's shown over here. So we can see it's a lot more trouble to draw out the actual electrochemical cell than it is to show it in this compact form, which is why cell notation is so convenient. Notice also the phase boundary. So we have a phase boundary between the zinc and the zinc solution. We have a phase boundary between the zinc solution and the salt bridge. That's here. So remember, this is going to be a gel, and here we have our solution. Then we have a phase boundary between our salt bridge and the other electrolyte solution over here. So the phase boundary there. And we finally have a phase boundary between the two different solids, so between the silver salt and the silver. So that's how cell notation works.